So chain rule. Okay, so just a reminder is that if f of x is equal to u of v of x, then f prime of x is equal to u prime of v of x times v prime of x. Okay, so this is what we applied. This is the main rule. We did a few examples. Let's prove it now. Okay, so the first thing I'm gonna set up is, I know that f of x is u of v of x. So f of x plus h will be u of v of x plus h. Okay, so this, everybody agrees with this. Okay, and so f prime of x would be, as usual, my definition, limit as h approaches 0, f of x plus h minus f of x over h. Okay, so far? We're good? Okay, nice. So I'm going to replace f of x plus h by this, and v of f of x plus f of x by this. So this will be equal to, so basically f prime of x is equal to the limit h approaches 0 of, so u of v x plus h minus u of v of x, and all this divided by h. Okay, so far nothing new. Okay, and now this is where I'm going to start and be creative now. So I'm going to go u of v of x plus h minus u of v of x over, so instead of putting my h here, I'm going to times by something here over h. Okay, so I didn't change anything. It's this over h as before, but apparently I will multiply and divide by something. Obviously the same thing. Okay, so then I don't change the value of my function, my fraction. So what am I going to do here? So I'm going to cheat a bit. I'm going to go here and I'm going to see that I'm expecting to have u prime of v of x times v prime here. I'm supposed to get a v prime. So if I want this expression to be v prime, what do I need to put on top here? What do you think? For this to become v prime, when the limit, oh, I forgot to write the limit, by the way. So limit h approaches 0. I forgot to write the limits. Okay, so what, when h approaches 0, what expression here will give me v prime?
V of x plus h minus v of x.
Very good. So v of x plus h minus v of x. So this will be v prime. So obviously I have to divide here by the same thing, or else I'm changing the value. So I'm going to divide here by v of x plus h minus v of x. Okay, any questions so far? Okay, so this is, what I'm going to write now is a bit tricky, but first step of my proof, which is by the way the hardest of all the proofs that we've done so far, is this one, because we had to think of multiplying and dividing, and now I'm going to do something else now. Okay, but I just want to make sure that this is clear for now. Any question at this step? Would like me to repeat this step?
Yeah, can you repeat it maybe?
Yeah. Okay. So again, so here I'm supposing that you're okay with this. I'm just using the definition of the derivative. And then what I'm going to do is I'm going to multiply and divide this fraction by the same thing. Okay. So vx plus h minus vx plus h minus vx, top and bottom, I did not change the value. Okay, now why did I decide to multiply and divide by this specifically? Because I noticed that this here, okay, looks pretty much like v prime of x. Okay, that's by the definition. Imagine if this was v prime of x, this would be v of x plus h minus v of x over h. That's what I have here. Okay, so I'm slowly approaching what I'm aiming for. Okay. Turn on the sound. Okay. Is it okay? Understand?
Yeah, thank you.
Okay. Now, here there's no problem. Here I have to fix something here. So what I'm going to do, I'm going to put it. I'm going to write something here. I'm going to change, so Vx plus h minus Vx, which is actually a very small value when h is very small, okay, is equal to, I'm going to call it k. Okay, I'm just going to call this value here, I'm going to call it k. Okay, so this means that if I isolate v of x plus h, well, this will be equal to v of x plus k. Okay, I just isolated v of x plus h. First thing to notice. Okay, second thing to notice is that as h gets very close to 0, k also gets very close to 0, right? Because if h is very small, then this is getting close to v of x minus v of x, which is almost 0, right? If h is 0, then I'm going to have k 0. So the closer h is to 0, the closer k is to 0 as well. Any questions so far? Okay, so this is the tricky part here, I think. Okay, two tricky parts: adding, multiplying top and bottom by the same thing, and this little thing here. This, as h approaches 0, k approaches 0. This is a bit tricky. Okay, who would like me to repeat this?
Can you please repeat it?
Yeah. So is this okay? This step?
Yes.
Okay. So here, the only thing I did is that I'm very lazy with my hand. I don't want to write v of x plus h minus v of x. I want to write this k. I want to write k instead. That's what I'm doing. I'm calling this k. Okay? That's what I'm doing. Now, since I decided to call this minus this k, then if I isolate v of x plus h, and I send the v of x on the right side, I'm going to get v of x plus h is equal to v of x plus k. Is this okay?
Yes.
Okay. So that's the first thing I'm going to notice. Second thing I'm going to notice is that let's analyze k to a second. K is equal to the difference between these two functions, these two values of the function. But if h is very, very small, then v of x plus h is very, very close to v of x, right? Of course, we're talking about well-behaved functions. Okay, of course, there are functions not in this course that just go on forever. They just jump forever, and so on. No matter how close you are to 0, this difference could always be huge or infinity or whatever. But we're not going to talk about these crazy functions. Okay, so for this course, we're talking about nice functions. Okay, so for these types of function, as h approaches 0, k also approaches 0. Do you understand this?
Yeah.
That's it. Okay, because here you could see it better. V of x plus 0 is equal to v of x, well, plus 0. This has to be 0 as well. If h is 0, k is 0. Okay, so now I'm going to go back to this and replace with what I did here. So equals, my first fraction will be, so u of, so v of x plus h is v of x plus k. Minus, this is u of v of x. And then divided by, and the bottom, we said we call this k. This is my first function, my first fraction, which I was able to get rid of the h and express everything in terms of k. Yeah, it's not bad. Okay, my second function, my second, sorry, fraction, this one here, I'm going to leave it as is. So it's times v of x plus h minus v of x, and this is over h. Okay, and all this, there's a limit in front as h approaches 0. So I'm going to apply the limit everywhere. So this will be the limit as h approaches 0, and this will be the limit as, oh, there's no more h here, there's k, but we said that when h approaches 0, k as well also approaches 0, so I'm going to do as k approaches 0. Are you with me so far? Okay. Equals. Now this, what is this?
Derivative of v.
This is what? Sorry?
The derivative of v.
Yeah, so it's v prime of x. Perfect. And what is this? So u of something plus k minus u of that thing over k. Well, that's also the derivative. That's also u prime. But instead of being x plus k and x here, it's v of x and v of x. So it's going to be of, instead of being of x, it's going to be of v of x. And that's my proof. Okay, I showed, I'm going to show you the theorem. 2 seconds. Can I fit it? There you go. So u prime of v of x times v prime of x, u prime of v of x times v prime of x. The proof is done.
Sir, can you repeat the last step again?
Yeah, of course. Okay, the last step, I agree, it's a bit tricky. So this shouldn't be too difficult for you, knowing that this is this. Is that okay for you?
Yeah, that I understand.
Okay, so let's go back here. So let me just add a little note here. So u prime, can you see it's pencil? Can you see it? It's clear?
Yes.
Okay. So u prime of x, we know its limit as h approaches 0 of u x plus h minus u of x over h. Just read that. So let's say if it was u prime of w, this would be limit h approaches 0 of u of w plus h minus u of w over h. Agreed?
Yes.
Okay, so now if I follow the same logic, u prime of, let's say instead of being x or instead of being w, I have here v of x, then it would be limit h approaches 0, u of, well, instead of being x or w, I will have v of x here, plus k, sorry, or plus h or whatever, minus u of v of x and over h. That's it. Okay, same thing. This and this is the same thing, except this is I use the variable h here, I use the variable k. Same thing. Is it okay?
Yes.
Okay. So it's the same thing. It's a simple derivative formula here.
So instead of putting k, can we just put h like to begin with?
Where? Here?
Yeah, there.
No, because here I made the change. I express k as v of x plus h minus v of x.
Okay, no, there. Can we put h?
Where? Here or here?
Oh, the red.
Where? Sorry, where?
Okay, no, never mind.
No, tell me. I want to understand. I didn't understand. I just didn't hear.
I wasn't understanding why we have to put like a different letter. Like, why can't we just put let v? I don't know how to explain it.
Let v of x plus h minus v of x equals this. What's this?
Yeah, h.
H here? The same
Yeah.
as this one?
Oh, okay, never mind. Yeah.
It can be the same. Okay? If you put h, then you're saying that it's the distance between the values of the function is exactly equal to what you increased in the h. No, that's not true necessarily. Okay? Any questions so far? Okay, good. Okay, anyways, you could always refer back to the notes, okay, or the video if you have questions. Let's go. So let's now evaluate derivatives of trig functions. So differentiating trigonometric functions. Okay, so first thing I'm going to do is I'm going to remind you of some theorems, okay, some identities. Okay, so trigonometric, because we're going to use them now a lot. Okay, so of course we took a few classes to go over the identities, but it never hurts to see them again. Okay. So the first identity, the basic one, so sine squared x plus cos squared x equals 1. 1 plus tangent squared x is equal to secant squared x. 1 plus cotangent squared x equals cosecant squared x. Then tangent x is sine x over cos x. Then cotangent of x is equal to cos x over sine x. Secant x is 1 over cos x. Cosecant x is 1 over sine x. Okay, you don't need to rewrite them because you have them already in the class. We did it the other day. Just for your memory. And these are two important ones that we're going to use now. So sine of a plus b and cos of a plus b. Okay, so I don't know if you remember them, but sine of a plus b is sine a cos b plus sine b cos a, and cos of a plus b is cos a cos b minus sine a sine b. Okay, and the last two things that we did about using trigonometry, limit as x approaches 0 of sine x over x, we showed that it was 1, and the limit as x approaches 0 of 1 minus cos of x over x, we said that it was 0. Okay, so these are the main identities. Ruler. Okay, so let's keep this just background. And let's go with our first derivative. So first thing, oops. If f of x is equal to the sine of x, then f prime of x. You know what the derivative of sine of x is? Anybody?
Cos of x?
What is it?
Cos of x.
Yeah, it's cos of x. Okay, perfect. The derivative of sine of x is equal to cosine of x. Okay, so of course we have to prove this. Okay, so proof. Okay, let's go. So f of x is equal to sine of x. F of x plus h will be sine of x plus h. Okay, so let's go. What is the derivative? So f prime of x will be the limit as h approaches 0 of what? And tell me. What I write here?
F of x plus h minus f of x over h.
Very good. So f of x plus h minus f of x over h. Again, our definition. Okay, which we all remember where it comes from. It comes from the graph. You remember we did the approximation and finding the limit of the secant slopes, of the slopes that, right, the segments until it gets close to the tangent. That's where it comes from. Okay, so equals limit as h approaches 0. So f of x plus h will be then sine of x plus h minus f of x, which is sine of x, and then all this over h. Okay, let's go. Equals, let me continue here. Limit as h approaches 0. So sine of x plus h, what is that? What's sine of x plus h? Okay, so we have a identity up here for the sum, the sine of the sum of angles. Okay, so could you help me out here? I think it will be sine x cos h plus sine h cos x, and all this minus sine x, and then divided by h. Are we okay so far? All right. And now I'm going to do some algebra here, not too complicated. My first fraction will be this one. So it will be limit as h approaches 0 of sine h times cos x over h plus, and then my limit as h approaches 0 of what's left, which is sine x cos h minus sine x over h.
Sir, can you explain that again, like real quick?
The last step?
Yeah.
Okay, so I'm assuming the step before is clear?
Yeah.
Okay, good. So what I did here is I just separated my fraction into two fractions. First fraction, I took this one. Here it is. And whatever's left, this term and this term, here it is, over h, my second fraction.
Okay, thank you.
Okay? And what I'm going to do here is I'm going to extract whatever does not depend on h, so cos x comes outside. Because this one has nothing to do with h, so it's like a constant with respect to h. So I could pull it out, and sine h over h. And then here I'm going to extract a negative sign. Limit h approaches 0, so what's left? So it will be plus 1 minus cos h over h. That's what I have. Okay. I'll let you do 2 seconds to write. Okay,
Can you re-explain what you did for the one on the right?
this one here,
Yeah.
I just extracted, I pulled out a factor of sine, right? Because there's a sine x and a sine x. And I also pulled out a minus so that I recognize this form.
But when you pulled out the sine x's, how did it equal to 1 minus cos h?
If you pull out just sine, you would get cos h minus 1. Right? If you pull out sine x from both, you're left with cos h minus 1 here, right? Are you with me or no?
Sorry, can you re-say that?
Yes, of course. If you pull out a sine x here and here, okay, there's 2 terms, sine x cos h, sine x. I could pull out the sine x, could pull out the sine x. What's left? Cos h minus 1. Right? If I redistribute here, sine x, so minus sine x times 1 will give me minus sine x, and minus sine x times minus cos h will give me plus sine x cos h.
Okay, I get it. Thank you.
Okay, it's just simple factoring. Greatest common factor, I don't know how you called it, something like that. Okay, any other questions? We're almost done. And you always have no space, so we're almost done. Okay, so now this, we all know that it's a 0. See it here. And this, we know that it's what?
1.
This is 1, right? We've done enough exercises of this. So this term here vanishes, 0, and this is 1. And so I'm left with cos x times 1, so my answer is cos of x. Done, proven. Okay, so we just showed that the derivative of sine x, so if f of x is sine x, so f prime will be cos x. We just showed the derivative is cos x. Are there any questions?
Sir, we can't see. Can you lower it?
Excuse me?
We can't see. I can't see.
You can see what?
Like the last step. Yeah, thank you.
Okay, sorry. On my screen, it appears, so okay.
We could see it before.
Sorry?
We could see it before.
Okay.
It's only her.
Oh, okay, okay, perfect.
Could you repeat the last step?
The last step, I mean,
Raise
this one here?
You get cos.
Yeah. Do you understand this is 0?
Yeah.
Yes or no?
Not really.
Okay, because this from here.
Okay,
Oh,
that.
sorry. So I'm going to push it back 2 seconds. Okay, you see it here? You see that?
Mm-hmm.
So this, we proved it when we were doing limits involving cosine, involving trig functions. We showed that this is 0.
Yeah.
Okay, you could go back to the notes and you'll see the proof. Okay, and so since this is 0, so this whole term becomes 0. So this is out.
Yeah.
Okay, this is eliminated. Out. What's left? This here. And sine x over x when x is approaching 0, that's 1. Also, right? You know that.
Yeah.
So that's it. I have cos x times 1.
Okay, now I see it.
Cos x. Okay?
Yeah. Okay.
Can we move on?
Sir,
Yep.
I have a general question. You said that in your exams you add some proofs, like some questions will be like prove something.
Yeah.
Does that mean you will take like one of the ones we saw in class, or can it just be like a completely new?
It could be either or. It could be
Oh,
new. It could be new. Okay?
thank you.
But anyways, I'm going to send you my old tests. Okay? And you will see the type of questions there is. Okay? So there won't be any surprise, but you'll see there's always one question that's a bit annoying. Okay? It's a bit tough. But most of the at least 60% of the test should be straightforward, and then another maybe 20% a bit harder, and then another 10 a bit harder, and then the last 10 and that one question that's always a bit challenging. Okay, but you'll see. I'll send you at least 2 or 3 tests, old tests from practice, so you know what to expect. Okay, so are we okay with this so far? Let's go. Next. So number 2. So if f of x is equal to the cosine of x, then f prime of x is what? Anybody know this one?
Negative sine of x.
Yeah, negative sine of x. Okay, so let's try the proof. So f of x is equal to the cosine of x. F of x plus h is cosine of x plus h. And so f prime of x is, as usual, limit h approaches 0, f of x plus h minus f of x over h, which is equal to the limit h approaches 0 of cos of x plus h minus cos of x over h, which is, so if you base yourself on the identity, which is right here, which we just wrote, so cos of a plus b, cos a cos b minus sine a sine b, so cos of x plus h will be cos x cos h minus sine x sine h. Okay, so let's write it. Cos x cos h minus sine x sine h, and then all this minus cos x over h. Okay, so who's got questions at this step? All right, and so I'm going to do the exact same thing as we did for sine. So I'm going to separate this again into 2 fractions. This will be my first fraction, so it will be the limit as h approaches 0 of, so negative sine x sine h over h, and then plus limit h approaches 0 of, so cos x cos h minus cos x over h, which is basically the first and the last term are here. Okay, and the second term is right here.
Sir?
Yep.
I had a question about this step specifically.
Yeah.
How do we always take the middle term as one of the fractions and then the rest is the other one?
I don't know. Always, we just did 2 proofs. I mean, for these proofs, yeah, so we do. But there's no really always here what to choose. I just choose the middle one because I recognize sine h over h, and I know that this is going to be 1. This I recognize, you see?
Okay.
because the minus sine x, you know, I'll pull it outside. And I'm going to be left inside of the limits sine h over h, which is 1. Okay, so let's go minus sine x times limit h approaches 0 of sine h over h. And here I'm going to do like before, but now I'm going to pull out minus cos. And what's inside now? 1 minus cos h over h. Okay, so minus cos x times 1 is minus cos x like here, and minus cos x times minus cos h is cos x cos h like here. So I see I did not change anything. And we know that this is 0, and we know that this limit is 1. Okay, and so again, this term vanishes. This is 1, so negative sine x times 1 is just negative sine x. That's done, that's my answer. That completes my proof. Any questions before we move on? Okay. So let's go now to the derivative of the tangent. Okay, so the other ones are going to be much easier. Okay, so now that we know that the derivative of sine is cos and the derivative of cos is negative sine, we're going to use this a lot. Okay, we won't have to redo this every time. Number 3. So f of x is tangent of x. F prime of x is what? Can anybody guess this one? Unless you've seen it before.
Secant squared of x.
Yeah, so this is going to be secant squared of x. Okay, so let's prove this one now. Okay, so I'm not going to use the limit definition anymore. Okay, I'm going to use now differentiation techniques. Okay, so the first thing I'm going to notice is that f of x, which is equal to tangent of x, is actually equal to sine x over cos x. This we know. Okay, and so f prime, so this is just the derivative of the quotient. Okay, so I could use the quotient rule here. Okay, so the derivative of the top times the bottom minus the top times the derivative of the bottom, right? That's how you use the quotient rule, and divided by the bottom squared. Any questions at this step? Okay. And now the derivative of sine, we just proved that it's cosine. So cos x times cos x minus sine x, and the derivative of cos we said was negative sine, and then all this divided by cos squared of x. Okay, any questions? Good. Now cos x times cos x is cos squared x. And then minus sine times minus sine is plus sine squared x. And all this divided by cos squared x. Okay, and now sine squared plus cos squared is what? That's
1.
Very good. Over cos squared x. Okay, and that's equal to, it's like 1 over cos x, all this squared. Okay, and 1 over cos, we know that this is secant. So this is equal to secant squared x done. Proven. Okay, so much easier. We just use the quotient rule. Okay, number 4. There we go, right here. Let's try to fit it here. Okay, so if f of x now is the cotangent of x, show that f prime of x is negative cosecant squared of x. So what do we have here? F of x is equal to cotangent of x, which is equal to cos x over sine x, okay? Which means that f prime of x, quotient rule, so the derivative of the top times the bottom minus the top times the derivative of the bottom. And all this over the bottom squared. Okay, so it's equal to derivative of cosine is negative sine x times sine x minus cos x times cos x over sine squared x. Okay, so on top I could extract a minus 1. So I will have negative brackets sine squared x plus cos squared x over sine squared x. Okay, which is, so this is 1, so it's negative 1 over sine squared x, which is negative, so 1 over sine x squared, and that is equal to negative cosecant squared x. Done. Any questions? Okay, so only 2 more left. We have to show the secant and the cosecant derivatives. And then these derivatives you have to know by heart, okay? Okay, let's go with the secant now. This is number 5, I think. 5. So if f of x is equal to the secant of x, then f prime of x will be equal to the secant of x times the tangent of x. Okay, so f of x is equal to secant of x, and secant of x is 1 over the cosine of x, which is equal to actually cos of x to the power of minus 1. Okay, that's what it is. And there's 2 ways I could do the derivative now. Either I do the quotient rule here, or I do the chain rule here. I personally prefer the chain rule here. It's up to you guys. But maybe I'll do both. Okay, I'll do both. So f prime of x is going to be the derivative of the top times the bottom minus the top times the derivative of the bottom, and all this divided by the bottom squared. Okay, so let's derive this. The derivative of 1 is 0 times cos x minus 1 times, this is negative sine x, and all this over cos squared x. Zero. What's left? Sine x over cos squared x. Okay, which I could rewrite as 1 over cos times sine over cos, which is secant times tangent. Okay, prove it. Okay, so this is using the quotient rule. Are you following? Anybody have trouble with this? And now here using the chain rule. So I'm going to use this now. How do we derive to the power of minus 1? So I'm going to put the minus 1 in front. Minus 2 times the derivative of the inside. So it's negative cos x to the minus 2 times negative sine x. Minus times minus disappears, so I have sine x over, because this is the minus 2, cos squared x, and I'm exactly at this spot now. So it's again 1 over cos times sine over cos, which is secant times tangent. Done. Okay, so this was using quotient rule. And this was using chain rule. Okay, let's do the last one. Okay, number 6. So f of x is equal to the cosecant of x. Then f prime of x will be negative cosecant x cotangent x. Okay, proof. So I'm just going to do, well, I'm going to do one of them, one of the proofs. Okay, so I will do the using the chain rule because I find it much simpler. Okay, so f of x is equal to the cosecant of x, which is cosecant is 1 over sine x, which is sine of x to the minus 1. Okay, so f prime of x will be, so the derivative of this is minus 1 times sine x to the minus 2 times the derivative of the inside. Okay, and that is negative sine x to the minus 2 times, this is cos x. And so that is negative cos x over sine squared x. And that is negative, so 1 over sine x times cos x over sine x, which is negative cosecant x cotangent x, and we're done.